बिस्मिल्लाहिर्रहमानिर्रहीम सल्लल्लाहु अलैहि वसल्लम अल्लाहुम्मा रब्बि ज़िदनी इल्मा सल्लल्लाहु अलैहि वसल्लम आमीन अल्हम्दुलिल्लाहि रब्बिल आलमीन। Differential equation question number 10 of November 24. I did this question in my last class. So the next question is question number 10 of November 24 paper 3-2. One minute please, let me share this link. Well, I'm using full screen. I have also opened YouTube on my phone so I can read your comments. Let's start the class. A balloon in the shape of a sphere has volume V and radius R. Sphere, so we must know the volume of a sphere, it's 4/3 pi r cube. Air is pumped into, that means inflow rate, at 40 pi when T is 0 and R is 0. At the same time, air begins to flow out, that means outflow of the balloon at a rate of 0.8 pi r. The balloon remains a sphere at all times. So, in order to prove this differential equation, we first need to write the given information. Net rate of volume, it's inflow rate minus outflow rate. So net rate dV upon dt, inflow is 40 pi whereas outflow is 0.8 pi r. Now this is dV upon dt. Now write the formula of volume of a sphere, it's 4/3 pi r cube. Differentiate it. Okay, we need more space. We don't have enough space for this part. Write this formula here and differentiate it because we would need it in chain rule. So it's 4 pi r square, the differential of V. How do we know we have to apply chain rule here? It's very simple. One rate is given and other rate is required. Rate of volume is given and rate of radius is required. So whenever two rates are discussed or involved in a question, then always use chain rule. So chain rule is dV upon dt, dV upon dr, dr upon dt. That's the chain rule. So 40 pi minus 0.8 pi r is here. dv upon dr, it's 4 pi r square. Dr upon dt, we have to prove it. So divide 4 pi r square on other side, or you can take pi common first. So cancel this pi, and this pi. So 40 upon 4r, this will become 10 upon r square. 0.8 r upon 4r, it will become 0.2 upon r. This is dr upon dt. So dr upon dt is 10 upon r square minus 1 upon 5r. You can write 0.2 as 1 upon 5. Now if we will take LCM, we will get the required equation. 5r square 50 minus r. This is what we had to prove. So this was the first part of this question 10. Now we need quotient and remainder when 5r square is divided by 50 minus r. So with the help of long division we can do this. 5r square is divided by 50 minus r. Make sure you write divisor in descending order. Remember, in long division we write both dividend and divisor in descending order. Now divide this by first term minus r. So 5r square minus r will become minus 5r. Now multiply minus 5r with this. So we will get 5r square minus 250r. Now opposite the signs. Cancel 5r square with 5r square. So left over is 250r. Now divide 250r by minus r. You will get minus 250. Multiply minus 250 with minus r will give you 250r. And then multiply minus 250 with 50. That will give you 1250. Now change the signs. And the remainder is 1250. This is 12500. 250 times 50 is 12500. So the quotient is minus 5r minus 250. And the remainder is 12500. That's it. This was part B of this question. Next part. Solve the differential equation in part A. So first copy the equation. It's dr upon dt is 50 minus r upon 5r square. Now do variable separable. So dr 5r square upon 50 minus r, and here we have dt. This is the variable separable. I shifted this fraction on left hand side and shifted dt on right hand side. Now taking sign of integral on both sides. Now replace this by this quotient and remainder. You have done this in remainder theorem. Dividend over divisor is quotient plus remainder over divisor. This is what we have done in remainder and factor theorems in P3. So we can split this fraction as quotient, and the quotient was minus 5r minus 250 plus remainder, which was 12500, over divisor, which was 50 minus r. So with the help of this remainder theorem, we can split this fraction in this way. So make sure you split the fraction correctly. Now taking sign of integral with each and every term. And dr as well. On right side we have just dt integral. Now we have to integrate all the terms. So minus 5r will become minus 5r square upon 2 minus 250r plus 12500 copied ln 50 minus r is upon minus 1. The differential of minus r is minus 1, and t plus c. You can call it equation 1. Now substitute the given information T0 and R0. So T0 and R0. So we will get 0, 0, minus 12500 ln 50 C. So C is this minus 12500 ln 50. Now substitute C here. So minus 5r square upon 2 minus 250r minus 12500 ln 50 minus r. I'm shifting C on left side because I have to make T subject. So when we will shift C on left side, it will become minus C. So minus C is plus this. See, if I will replace this value here, I will get minus 12500 ln 50 here. So when I will shift this on left side, I'll get plus. So make sure you write this step carefully. You can do this in next step as well. So this is T. And this is what we had to find. The question was find the differential equation of T in terms of R. This is done. Now find the value of T when the radius of the balloon is 12. Very simple. We just need to put 12 here in this equation. So T when R is 12. 5, 12 square, 2, 250, 12, 12500 ln 50 minus 12 makes 38, 12500 ln 50. You can use your calculator and get the value of t. The value of t would be 70.5. So this is the second important question of differential equation. The first part A was important. Part B was also important. But how to prove differential equation? This part is very important. We use chain rule here. Okay, you can just go through the solution, just check the solution. I'm taking 1 minute break and then I will do the next question. Next question. Another very important question, and this question is from June 24, paper 3-2, question 10. This question. This is the third important question. This is very important. By writing y is equal to sec cube theta as this, show that dy upon theta is this. So first write sec cube theta as one upon cos cube theta. Now bring cos cube theta in numerator. So it will become cos theta whole power minus 3. Remember, cos cube theta can be written as cos theta whole power 3. We can write this power as a whole power. Now differentiate this. So dy upon d theta. Differentiate this by means of composite function. First make power coefficient, copy the function, subtract power by 1, so minus 4, differentiate cos theta. The differential of cos is minus sign. So we will get 3 sin theta upon cos power 4 theta, and cos power 4 theta will become sec power 4 theta. This is what we had to show. Now one very important thing which will be used in the later part. See, we can write this as d upon d theta cos, or we can say sec, this sec cube theta, as 3 sin theta sec power 4 theta. See, this is very important. When we differentiated sec cube theta, we got this answer. We got this answer when we differentiated sec cube. So we can write this as d upon d theta sec cube theta is this 3 sin theta sec power 4 theta. This will be used in the later part. Now the part B, solve this differential equation. So first we need to do separable. First copy the equation, then do separable. Now shift dx on other side with x square plus 9 and bring cos power 4 theta on left side. So sin theta copied, cos power 4 theta is here, d theta. On right side we have x plus 3 over x square plus 9 dx, taking sign of integral on both sides. We can also write this as sin theta sec power 4 theta, and here we can break the LCM. Three upon x square plus 9. Now this is very important. See, this thing is here. This 3 is extra. So bring 3 on left side. D upon d theta sec cube theta over 3 is equal to sin theta sec power 4 theta. Now understand this very carefully. When we differentiate this, we get this result. This is differentiation. So when we will integrate this, we must get we must get this thing. So the integral of this should be this, and you have other option. You can replace this by this thing over here. You have two options. Remember, you have two options. Number one, if you would replace this by this thing here, you can solve this equation. This is the first option, the easiest option. Replace this result by d upon d theta sec cube theta over 3. This is the first option, and this is the easiest option. I'll tell you the other option as well. So x upon x square plus 9 dx, we can write 9 as 3 square, because this is the structure of tan inverse formula. So this is the first option and the easiest option. Replace this by this thing over here. Now this means differentiation. D upon d theta means differentiation, and this means integration. See, if I have this d upon d theta theta and d theta, then this factor means differentiate theta. So when we will differentiate theta, we will get theta square. We will get 1. The differential of theta is 1. And then when we will integrate 1, we will get theta. So this means differentiation, this one, and this means integration. So if you will differentiate theta, you will get 1. And if you will integrate 1, you will get theta. So you will get the same thing. When you will differentiate it and then you will integrate it, you will get the same thing. So remember, if we differentiate something and then if we will integrate the answer, we will get the same thing. Theta, see, theta is here. So according to this rule, see, this is the differentiation, and then we will integrate, when we will differentiate it, we will get this answer, something, and when we will integrate the answer, we will get the same thing. So just copy this thing. Sec cube theta over 3. The other way, if you see this thing and this thing, both things simultaneously, d upon d theta differentiation and integration, just copy this thing here. This is the easiest way, because you will get the same thing. Now this is basic formula 2, ln x square plus 9 over 2. The differential of x square is 2x. X is there, 2 was missing. Now this is the structure of tan inverse. So write reciprocal of this constant here, tan inverse x upon 3. The fraction of these two should be here. Now given information is x is 3 and theta is pi by 3. X is 3 and theta is pi by 3. So sec, we can write sec as 1 upon cos. So cos pi by 3 whole cube. The reciprocal of sec is cos. X is 3, so we will get 18 here over 2. These 3's will be cancelled. So tan inverse 1. 3 upon 3 is 1, so tan inverse 1. Cos pi by 3 is half. So we will get 1 upon 2 cube here. ln 18. You can write this as tan inverse 1 is pi by 4. Here I forgot to write C, so C is here. So C, this will become 8 upon 3 minus ln 18 upon 2 minus pi by 4 is equal to C. Now substitute this into equation 1. So sec cube theta upon 3 is equal to half ln x square plus 9 plus tan inverse x upon 3 and c is 8 upon 3 minus ln 18 upon 2 minus pi by 4. The question is, solve the differential equation to find the value of cos theta when x is 0. Now substitute x0 into this equation. So write this as 3 cos cube theta half ln 9, because x is 0, tan inverse 0 is 0, 8 upon 3 half ln 18 minus pi by 4. Now use your calculator and get the value of this entire thing, and then multiply the result by 3. So do this calculation very carefully. I'm writing the value of cos theta directly. You can manage this with the help of your calculator. 0.601. Make sure your calculator must be in radian mode. So this question is over. The first part of this question was very important, this part, and we use this result in the later part. Okay, last question of this class, because at 5:30 Asr prayer is the time of Asr prayer. So I'm going to do the last question. And this question is from November 24, paper 33. Question 10. This one. This is the fourth important question. A water tank is in the shape of a cuboid with base area of 40,000. At time t minutes, the depth of water in the tank is 8 centimeter. Water is pumped into, that means inflow, and water is leaking outflow, and we have to prove depth. So the rate of change of volume is given, and we have to prove rate of change of depth. So we need to use chain rule. Number 1, copy the formula of cuboid, volume of cuboid, base area into height. So base area is 40,000, height is small h. So differentiate this. We have space, we have enough space for this part. So dV upon dH is 40,000. Now copy the given information. Net rate of volume, inflow, which is 50,000, outflow is 600 H. Now use chain rule. Chain rule is dV upon dt, dV upon dH, dH upon dt. Just 1 minute. Okay, now substitute dv upon dt, which is 50,000 minus 600h. dv upon dh is, I guess, 40,000. dh upon dt is copied because we have to find dh upon dt. Now cancel two zeros on both sides of each and every term. So we have 500 upon 400 minus 6 upon 400 h dh upon dt. We have to keep 200 on left side, so $200 means we have to divide all terms by 2. So 500 upon 2, 6h upon 2, 400 upon 2. In this equation we have 200 here, so we have to divide all terms by 2. So we have 250 3h 200 dh upon dt. This is what we had to show. Now you can check this solution. Now the next part. It is given that t is 0 and h is 50. Find it. Okay, we have to solve this equation. So first copy this equation. So it's 200 dh upon dt I guess 250 minus 3h. Now do variable separable. So 200 upon 250 minus 3h dh dt. Now taking sign of integral on both sides. Now bring this 200 outside the integral and integrate this by means of ln. So 200 ln modulus 250 minus 3h over minus 3, the differential of minus 3h, and this is t plus c. So adhan is going on, so just wait 1 or 2 minutes. اللهم رب هذه الدعوة التامة. الحمد لله رب العالمين. Now we need to substitute T0 and H50. So it's minus 200 upon 3 H50. When we will put 50 here, we will get 150, so ln 100. And T is 0. So C is minus 200 upon 3 ln 100. Now substitute this information into equation 1. So we have minus 200 upon 3 ln 250 minus 3h T minus 200 upon 3 ln 100. Now bring this term on left side. So we have T is equal to, or we can say T is equal to minus 200 upon 3 ln 250 minus 3h plus 200 upon 3 ln 100. We can take 200 upon 3 common. So we have ln 100 minus ln 250 minus 3h. Now we can apply quotient law. So 100 upon 250 minus 3h. This is the required differential equation. T in terms of h. Now we need time when depth is 80. We have to put 80 into this equation. So h is 80. So T is equal to 200 upon 3 ln 100 250 minus 240, because h is 80, so 80 times 3 makes 240. So 200 upon 3 ln 100 upon 10, so ln 10. That's the exact value in terms of ln, and the other number is 150. So there are two answers in terms of ln and numerical value. You should give the numerical value because it was mentioned find the time taken when depth is 80. So this was another question of differential equation, important question, and inflow outflow was used in this question as well. So I have done 4 questions of differential equations, 3 in this lecture and 1 in the last lecture. So those who will get time, your friends, if they would get time, you should ask them to watch these 2 lectures. These lectures would help them to solve the differential equations well. So inshallah I will try to keep a class of vectors, either vectors or complex numbers tomorrow. I will try. So if you think this lecture is helpful, then do share the link of this lecture with your friends. Also like the lecture and subscribe the channel as well. Good luck. I hope you will do well in your P3. Good luck to everyone. Allah Hafiz.